Let's look at summation using logarithmic series. Now the theorem associated with it is if x is between 1 and -1, then natural log, or it can be also written as log to the base e, 1 plus x is equal to x minus x square by 2 plus x cube by 3 minus x4 by 4 and so on. The nth term being minus 1 to the power of n minus 1 x to the power of n by n and so on. This is called the logarithmic series. Now let's take this and let's substitute x with minus x. So what do we get? We get natural log of 1 minus x is equal to minus x square by 2 minus x cube by 3 minus x4 by 4 and so on, which means we can take out this minus which is common to all of them. So x plus x square by 2 plus x cube by 3 and so on, and this minus can be brought on to this side, is equal to x plus x square by 2 plus x cube by 3 and so on. Now let's add this and this. What do we get? Natural log of 1 plus x plus minus natural log. So minus natural log of 1 minus x. So let's add this. So basically we are going to add the expansions. This x and this x will add up, whereas x square by 2 and x square by 2, there it is minus, here it is plus, so that will cancel out. So what you will end up with is x plus 2x plus x square by 2 cancels out, 2 times x cube by 3 plus 2 times x to the power of 5 by 5 plus 2 times x to the power of 7 by 7 and so on. 2 is common to all of them, so let's take it out. We get x plus x cube by 3 plus x5 by 5 x7 by 7 and so on. Now this 2 can be taken to the other side, but before that let's simplify the left hand side as well. So you know the log rules. So natural log of 1 plus x by 1 minus x, that subtraction can be converted to division, and this 2 can be brought on to this side. So 1 by 2 natural log of 1 plus x by 1 minus x is equal to x plus x cube by 3 plus x to the power of 5 by 5 plus x to the power of 7 by 7 and so on. So basically we know now the expansion of natural log of 1 plus x is this, or in other words, if we get this pattern in a series, we know we can substitute it with natural log of 1 plus x, and same way with respect to this as well. Now let's say if I put x equal to 1, then what happens? So let's take natural log of 1 plus x. So instead of x I put 1. What happens then? Wherever we have x, let's substitute it with 1. So 1 minus 1 by 2 plus 1 by 3 plus minus 1 by 4 and so on. So here it was x square, 1 square is 1, x cube, 1 cube is 1. So, and this we know is monotonic decreasing sequence or series and tends to 0, and by Leibniz rule is convergent. So which means log of 2 can be evaluated using this series 1 by 2 plus 1 by 3 minus 1 by 4 and so on. Okay, so purely based on this much, let's solve some problems just to get a feel of it. Okay, so let's say the series is 1 by 3 plus 1 by 3 times 3 cube plus 1 by 5 times 3 to the power of 5, 1 by 7 times 3 to the power of 7 and so on. Now if this is what we have to figure out, then what happens? So here if you notice, you have to recognize the pattern. So we need to have some kind of a x square, x cube, x4 kind of thing. So let x be equal to 1 by 3. So the moment we do that, what happens? This series becomes x plus 1 by 3 x cube plus 1 by 5 x to the power of 5 plus 1 by 7 x to the power of 7 and so on. And the moment we do that, we should recognize the pattern. And this pattern is 1 by 2 log of 1 plus x by 1 minus x. And once we recognize the pattern, we know the formula and just a question of substitution and simplification. So 1 by 2 log of 1 plus 1 by 3 by 1 minus 1 by 3. 1 by 2 log 1 plus 1 by 3 is 4 by 3. 1 minus 1 by 3 is 2 by 3. So 3 gets cancelled. 1 by 2 log 4 by 2, that is 2. You can take it a little bit further as well. So this half can go up based on log rules, and this is nothing but log of root 2. Okay, let's look at the next problem. Let's say the series given is 1 plus x by 3 plus x square by 5 plus x cube by 7 and so on. Now what do we do? Now many times it doesn't match the pattern. So somehow you have to make it match a pattern. So here, what doesn't match? If you notice here it should be x square by 2, x cube by 3, something like that has to be there. So what do we do? So here we have 5, so on top it should be x to the power of 5. Here it is 3, we should have x to the power of 3. So we have to increase the power of x. So let's say x is equal to t square. So if we do that, what happens to this? 1 plus t square by 3 plus x square will be what? t4 by 5 plus t6 by 7, right? We still require one more additional t's, right? Here it is 3, here it should be cube, here it is 5, it should be power of 5. So let's multiply the entire series by 1 by t, and to balance that, let's multiply all the terms by t. So basically we are multiplying each of the terms by t by t. So this becomes t cube by 3 plus t5 by t plus t7 by 7 and so on. Now this is a pattern that we recognize, and this is equal to 1 by 2 natural log of 1 plus t by 1 minus t. Now we know x is equal to t square. So t would be equal to what? Square root of x. So 1 by 2 root x natural log of 1 plus root x by 1 minus root x. So that is the solution. Let's do the next one. S is equal to 1 plus 1 by 4 times 1 by 2 plus 1 by 3 plus 1 by 4 square times 1 by 4 plus 1 by 5 and so on. Now here x is equal to 1 by 4. So which means square root of x is equal to 1 by 2. So our series can be written as 1 plus 1 by 2 plus 1 by 3 x plus 1 by 4 plus 1 by 5 x square and so on. Now what we can do is split it up into two separate series. So 1 plus, in one series we take all the odd denominators, right? So 1 by 3 x plus 1 by 5 x square and so on. And in the other one we take all the even numbers. So x by 2 plus x square by 4 plus x cube by 6 and so on. And we recognize these patterns. So this is nothing but 1 by 2 root x times natural log of 1 plus root x by 1 minus root x. 1 by 2 minus natural log of 1 minus x. So this would be 1 by 2 times 1 by 2. Natural log of 1 plus 1 by 2 by 1 minus 1 by 2. Minus we take it out. So 1 by 2 times natural log of 1 minus 1 by 4. Natural log of 3 by 2 by 1 by 2. So 2 gets cancelled. Minus 1 by 2 natural log of 4 minus 1 3. 3 by 4, which is equal to natural log of 3 minus natural log of 3 by 4 to the power of 1 by 2. We can take it up. So natural log of 3 minus natural log of root 3. And this 4, division by 4, log rules, we can take it out. So it becomes minus log 4. But because of this minus, it becomes plus. So plus natural log of 4 to the power of 1 by 2 or square root of 4. This minus natural log 3. This minus we can take it up. So it becomes to the power of minus 1. So which means this, if we make this plus, this becomes natural log of 1 by root 3 plus natural log of 2. Now again log rules, when we have additions, we can multiply them. So 3 times 1 by root 3 times 2. So natural log of 6 by root 3, natural log of 6 root 3 by 3. So the answer is natural log of 2 root 3. Let's do the fourth one. Let's say the series is 1 by 1 times 2 minus 1 by 2 times 3 plus 1 by 3 times 4 minus 1 times 4 times 5, 1 by 4 times 5 and so on. Now nth term is going to be minus 1 to the power of, it is plus minus, so n minus 1. So 1 minus 1 is 0. So this is 1. So great. When it is 2, 2 minus 1 is 1. So minus 1. Okay. And all the numerators are 1. And here you have n times n plus 1. N times n plus 1. Now let's take this 1 by n times n plus 1. We need to split it into partial fractions. So a by n plus b by n plus 1. Very quickly I'll do it. N plus 1 a times n plus 1 plus b n. 1 by n times n plus 1. This and this gets cancelled. So now let's say n equal to 0. If we put n equal to 0, what happens? We get 1 is equal to a times 0 plus 1 plus 0. And we get a equal to 1. Now if we put n equal to minus 1, we get 1 is equal to a minus 1 plus 1 plus b times 1. So this gets cancelled, 0. So this is b is equal to 1. So which means our fraction can be split into 1 by n minus 1 by n plus 1. Whole series of videos are there on partial fractions. It's a separate playlist. You can have a look at that. Okay, so our series actually becomes summation of n equal to 1 to infinity of minus 1 to the power of n minus 1 times 1 by n minus 1 by n plus 1. This we can split it into 2. N equal to 1 to infinity of minus 1 to the power of n minus 1, 1 by n minus n equal to 1 to infinity of minus 1 to the power of n minus 1 times 1 by n plus 1. This if we expand it and write, we get 1 minus half plus 1 by 3 minus 1 by 4 and so on. And this if we expand it, we get 1 by 2 minus 1 by 3 plus 1 by 4 and so on. And these are the patterns we recognize, right? This is nothing but log 2. Yes. Now let's take this minus inside. So this becomes plus minus 1 by 2 plus 1 by 3 minus 1 by 4 and so on. And if you notice, this series and this series is same. The only thing is 1 is missing now. So this is log 2 plus log 2 minus 1. This is 2 log 2 minus 1, which means log 2 to the power of 2 minus 1, which is equal to log 4 minus 1. So that is summation using logarithmic series. I think that's enough for today. Bye for now.